In this video, we will talk about motion of objects in one dimension. We will explain position vectors, the difference between distance and displacement, and difference between average speed and average velocity. In particular, we will learn to define and calculate these physical quantities from solved examples. So let's begin. Position vector is a vector that specifies the position of a point or the position of an object situated at a point. In this video, we shall restrict our discussion to one dimension only. Suppose you have a point P, as shown, whose x-coordinate is 4. How do you define position vector of this point P? The position vector is defined from the origin to the point in question. Thus, it can be sketched like this. So that is the position vector of point P. Now, how do we label it? We label it like that. Rp equals 4i hat. 4 is the magnitude of the position vector and I hat is the direction of that position vector. Now, the usual unit is the unit that quantifies length, such as meter, or kilometer, or miles, and etc. Another example, let's say you have a point Q on the negative side of the x-axis. So what is the position vector of this point Q? Again, it should be directed from the origin to the point Q. So it should look like that. So that is the position vector. The blue arrow is the position vector of that point Q. And the way we write the position vector is vector r sub q equals minus 5i hat, like that. Now likewise, let's say you have point B with y-coordinate of 7. So the position vector of vector B of point B will extend from the origin to the point B, as shown. Now the way we write this position vector is, as before, subscript B equals 7j hat. Next, point C with y-coordinate of minus 6, and its position vector is given by that blue arrow, and the way we write it is r sub C equals minus 6j hat, and so on. Next, let's look at the concept of distance. Distance is a scalar, which means it does not have any direction associated with it. The SI unit to measure distance is meters. You can use other non-SI units to measure distance as well, such as kilometers, miles, and so on. Let's assume there is an object and it moves from the origin to point A first, which is at a distance of 4 meters from the origin, and then it reverses its direction of motion and it heads back to point B and stops there. So in this case, what is the total distance traveled by this object? Well, the total distance is given by 4 meters for the first leg, and then 4 plus 7 of the second leg of the motion. So together, the total distance for this motion is 4 plus 4 plus 7, so 15 meters. So distance is defined as the actual amount of meters or kilometers or miles or whatever units that you choose to define the distance the object covers throughout its journey. So direction does not matter here. Another example, for this motion along the y-axis, let's say the object moves from point Q all the way up to point P, and then comes back to point Q, as shown by the two arrows. What is the total distance here? So the total distance here is, you have 8, let's say the units are meters, 8 meters, 8 meters, 8 meters, 8 meters. So the total distance is 16 plus 16 which is 32, say, meters. That is the total distance traveled for this journey. Next, let's talk about displacement. Now, displacement is a vector, and it's defined as change in position vector of an object as the object moves from an initial point to a final point. For example, if you have an object that moves from an initial point I to a final point F, as shown by that blue arrow, the position vector of the initial point is labeled as Ri, the vector Ri, and that is the position vector of the initial point, and this is the position vector of the final point. So in this case, the displacement vector for this motion is given by the position vector of the final point minus the position vector of this initial point. And this is how we define displacement. So if you have an object that is going from point A to point B, A with an x-coordinate 5 and B with an x-coordinate of -5, what is the displacement in this case? So A is the initial point, B is the final point. The position vector of the initial point is the position vector of point A, which is 5i hat, let's say meters. The position vector of the final point is the position vector of point B, which is minus 5i hat, let's say the unit is meter. So the displacement vector for this motion is given by RB minus RA, which is minus 5i hat minus 5i hat, which is minus 10i hat meters. So that is the displacement vector for this motion. Let's look at this particular example. An object goes from point P to Q and then back to P, as shown by those two red arrows. What is the displacement for this particular motion? So the displacement vector in this case is given by the position vector of the final point. So the final point is P, so we can write RP, and the position vector of the initial point, which is also P, so RP minus RP. So meaning in this case it's 4j hat, because the position vector of point P is 4j hat, minus 4j hat is 0 vector, 0 meters. So that is the displacement for this motion in this particular example. As you will see in a few minutes, this concept of displacement is very crucial, it's very important when we calculate average velocity later. Now let's look at average speed. So what is speed? Speed measures how much distance is covered in 1 unit of time. For example, how many meters is covered in 1 second. So if an object has a speed of, let's say, 10 meter per second, that means the object, as it moves, it covers a distance of 10 meters in 1 second. That's what it means. Now we shall refer to average speed for the time being. Now average speed means we don't care about the details in between. So maybe as an object, let's say, as it moves from point A all the way to point B, it can do so in a number of ways. It can speed up and then slow down and then speed up again, or it can move in certain ways, stop and then start moving, and so on and so forth. So for that reason, we are interested only in the average speed of the journey as the object moves from point A to point B. Now how do we calculate this average speed? What is the formula for it? So to calculate average speed, this is the equation that we use. We use distance traveled over time it takes to cover that particular distance. So if you have an object moving between, let's say again from point A to point B, distance 100 meters apart, and it takes, let's say, 5 seconds to do it, then the average speed of this object is given by 100 over 5, which is 20 meter per second. As simple as that. Now average velocity. Average velocity is a vector, so direction matters here. Now this is the expression that we use to calculate average velocity. So average velocity is defined as displacement over time to cover the displacement. So this is the displacement vector that we talked about earlier, and this is the time interval it takes to cover that much of displacement. Now one thing to note about any velocity is that the direction of velocity, because velocity is a vector, so we have to talk about its direction. The direction of velocity vector is the same as the direction of motion of this object. So when we talk about velocity, we have to say something like this. An object is moving, let's say 10 meter per second, maybe rightward or leftward or northward or southward. So the direction must also accompany its description. Let's look at a simple example. The position of an object along the y-axis is given by this expression. As time changes, the position, the y-coordinate changes. That's what it means. Now find the displacement vector of this object from the second to the fourth second, and also calculate the average velocity between these two times. So first let's calculate the y-coordinate of this object when t is 2 seconds. So you substitute t equals to 2 in that expression given, and you end up with minus 2 meters, which means the object is somewhere here, minus 2. And at t equals to 4 seconds, the object's coordinate, the y-coordinate, is 12 meters, as shown. So that means it's here. So the object has traveled from t equals to 2 to t equals to 4 in the direction shown by that red arrow. So this is the initial point, this is the final point. So the displacement can be calculated using its definition. The final point position vector minus the initial point position vector. So the final point position vector is 12j hat, and the initial point position vector is minus 2j hat. So you get a displacement of 14j hat in meters. Having found the displacement, the average velocity can be found from the following equation. So we know the displacement vector was 14j hat. The time interval is 2 seconds because it's 4 minus 2. So you end up with 7j hat meter per second for the average velocity. Now let's try to understand the concept of average speed versus average velocity from using the example below. You have an object that's moving 40 kilometers in 1 hour, and then it continues moving along the same direction for another 40 kilometers, but now taking 1.5 hours to do it. What is the average velocity and average speed for the trip? So the average speed can be calculated in the following way: distance over time. So the total distance is 80 kilometers, and it is completed in a complete time of 2.5 hours. So it's kilometer, and this is in hours, which gives us 32 kilometers an hour. Now what about the average velocity for the trip? The average velocity is given by the displacement. So the displacement, as you can see, is 80 I hat minus 0 I hat, because this is the final point and this is the initial point, and that would give you an average velocity of 80 I hat over 2.5, and that's going to be 32 I hat kilometers an hour. Now what about if the object goes and come back to the same point? So in this case, the distance traveled is the same as before, which is 80 kilometers in the same amount of time, 2.5, and it has the same average speed of 32 kilometers an hour. The average velocity is 0 in this case because the displacement is 0 since the initial and final points are the same. So the magnitude of the average velocity and average speed need not be the same.